The Industrial Revolution is happening now. Jobs, growth, efficiency, productivity, independence. American manufacturing is critical to our economic growth and global competitiveness. Manufacturing employs nearly 13 million workers in the United States, adds more than $2 trillion to the U.S. economy, and generates about 12% of the U.S. gross domestic product. Every dollar spent in the U.S. manufacturing sector generates up to $1.81 in other services and production. The U.S. Department of Energy's Advanced Manufacturing Office promotes American energy dominance, keeping the nation out front in sustainable and efficient manufacturing, where cutting-edge technologies and innovations are foundational to a growing, competitive economy and job security in the United States. The only such entity in the U.S. government, the Advanced Manufacturing Office, bridges the gap from laboratory to market by connecting manufacturers, not-for-profit entities, research organizations, and institutions of higher education to identify challenges, spur innovation, and develop cutting-edge materials, processes, and information technologies needed for an efficient and competitive domestic manufacturing sector. Since 2018, the Advanced Manufacturing Office has supported our partners with more than $180 million in funding opportunities designed to uncover the next big thing in manufacturing, the breakthrough that will help our partners stimulate technology innovation and improve the energy productivity of U.S. manufacturing. We pursue our goals through 3 sub-programs: individual advanced manufacturing applied research and development, R&D projects, pre-commercial advanced manufacturing R&D consortia, and technical partnerships. Industry benefits greatly by having access to world-class research experts at our 17 national laboratories, where researchers tackle critical scientific challenges at their specialized facilities. For example, at our manufacturing demonstration facility at Oak Ridge National Laboratory, we're working with private sector partners to develop additive manufacturing technologies, such as 3D printing, to produce stronger, lighter, and less expensive manufacturing parts and materials. We're also engaging with American innovators and entrepreneurs through federal prize competitions designed to help surface market-based solutions for some of our biggest energy challenges. And we have several manufacturing-related competitions that are focused on bringing energy training to energy innovators. The Advanced Manufacturing Office helps American manufacturers increase energy productivity while reducing emissions, industrial waste, water usage, and the life cycle energy consumption of manufactured products. We also promote a strong homegrown manufacturing base for domestic supplies of key products of importance. The bottom line is secure and reliable energy resources for national security. Let us help you achieve your manufacturing goals. Learn more at energy.gov/EERE/AMO.
Please join me in thanking the team in the AMO office for that overview of their work that their office supports. As you may know, the AMO office is one of 11 programs in DOE's Office of Energy Efficiency and Renewable Energy, or EERE. I'm very pleased to introduce Daniel Simmons, Assistant Secretary for Energy Efficiency and Renewable Energy, who will set the stage for our first panel. Mr. Simmons leads EERE in promoting affordable and reliable energy to enhance America's economic growth and energy security. He oversees technology development in the energy efficiency, renewable power, and sustainable transportation sectors. And Mr. Simmons, we were especially delighted to see the announcement last week, the Secretary mentioned it, about the new research collaboration based on large-scale bio-based additive manufacturing that brings together Oak Ridge and the University of Maine. Please, I want to thank you for this important initiative. We'll hear more from the Senator in just a few minutes. Please join me in welcoming Daniel Simmons today.
Thank you. Thank you very much. Thank you for the opportunity to be here. Thank you to the Secretary, Undersecretary DeBar, for his vision for meetings like this to bring people, to really bring people together with a shared goal and a shared belief in that manufacturing is a critical component of American prosperity. At DOE, we spend a lot of time thinking about, how do we advance manufacturing? And so in the office that I lead, the Office of Energy Efficiency and Renewable Energy, there's three key areas that we think about. The first is reducing energy burdens. That is both in terms of making sure that energy is affordable, reliable, and that we are being energy efficient. The second is advancing critical technologies forward, and then the third is energizing the workforce. So it is critical that we have affordable, reliable energy. This is one of the real challenges, and because my office includes renewable energies, where you have wind and solar, we are constantly looking at ways to make these sources of generation more valuable to the grid, so that as we're adding more wind and solar, that the grid is becoming more reliable than ever before, and more affordable. That is really the goal. Because electricity prices in the United States are 1/2 of what they are in the EU. They are 1/3 of what they are in Germany. Some of our main competitors in the manufacturing space, we are never going to have cheap labor in the United States, at least for many generations in the future. We can and we should have affordable energy. One of the ways that we need to work towards that is what my office works on in terms of energy efficiency. Just yesterday, I visited Eastman Chemical, and they are doing great work around energy efficiency using a program that the Secretary mentioned called the Better Buildings Program, Better Plants, where this is not a subsidy program, it's not a regulatory program, it is really a program of connecting businesses to experts at the national laboratories and other places to make sure that they have access to the best information modeling so that they can achieve their energy efficiency goals. And as a result of their energy efficiency program, the company is saving $39 million a year today versus where they would have been if they wouldn't have embarked on this project just a few years ago. And so that is a real success story. But energy itself, all the affordable energy, all the energy efficiency doesn't matter if we don't have innovation. Mo, who is leading this next panel, one of the things that he told me yesterday, one of the arguments he made to me, is that we need to innovate faster than our competitors copy. And this is key. That how do we accelerate innovation? How do we make sure that innovation continues at an incredibly rapid pace? And this is what our, as you saw in the video that the Advanced Manufacturing Office does. These are key areas. And if you had an opportunity to tour the manufacturing demonstration facility here at Oak Ridge, many of the other capabilities of the national laboratories, advancing technology, some of the key areas there is things such as XLab, bringing people together, because it is facilities. And the national labs have, world-class facilities, world-class, the fastest supercomputers in the world, and that is critical, that people know and understand what those facilities are capable of. But more important than that is the bringing people together, and which is one of the key ideas here today, to bring people together, but also to let people know about the great people that are at the national lab, so that we can stimulate innovation. And thirdly, talking about energizing the workforce. The Secretary talked a lot about STEM, the workforce of the future, and there are some critical things that the national laboratories are doing in this space around the Lab Embedded Entrepreneurship Program with Innovation Crossroads, which is these young people who have very innovative ideas. They get access to the facilities and the people at the national laboratories, and they are really coming up with some very interesting and exciting projects, and I look forward to seeing what they will do in the future. So I will turn it over to Mo, but I just wanted to say that I really believe that the future of manufacturing in the United States is bright, but we have to work hard to stay ahead of our competitors, to stay ahead of people that would take the hard work that is done and copy it, which which I hope, since Mo pitched me on that idea, it's one of the things that the panel will discuss. And I'm grateful to be here today and to share our work in advancing American manufacturing together. Thank you very much. And with that, I'll introduce Mo, one of the Associate Lab Directors here at Oak Ridge. Thank you, Mo.
Thank you, Daniel. Thank you. So good morning, everyone. We have actually a set of very outstanding panels today, and we're going to talk about driving American manufacturing and a renaissance in the manufacturing sector. So there's a lot of changes in communication and artificial intelligence and additive manufacturing. These communications are leading to an evolution in manufacturing that's faster than we ever really encountered in the past. Our decisions that we make today will affect jobs, exports, and the assurance of security, and the Secretary talked about energy and resources. The DOE is supporting multiple activities in manufacturing, in additive manufacturing across the national lab system, in high-performance computing for manufacturing to accelerate the technology development cycle. We see a lot of work in the area of composites. Lightweight materials are actually going to be with us. There's a lot of work in manufacturing related to batteries, roll-to-roll manufacturing, to cut the cost of making batteries. Electrification is very critical, so the department is making these investments. Clearly, these will have major impacts on the U.S. Economy and various sectors, the energy efficiency sector, the transportation sector, and the energy generation sector. As I said, electrification, lithium-ion batteries, and beyond lithium-ion batteries is critical. We need to think about mineral security in the United States, and we need to figure out how to advance energy storage in our country and how actually to be on the top of the pyramid, how we actually can dominate manufacturing in 2025. It's not really okay just to maintain. We need to figure out how we can dominate in 2025. As the Secretary mentioned earlier, Oak Ridge National Lab has been really advancing computing to simulate manufacturing processes and to analyze data for the whole notion of born qualified, born certified, and that's really what we're trying to drive at in the area of nuclear energy. It's not just about new advances in manufacturing, it's about really cutting cost. We have to cut cost of how we produce energy using nuclear such that nuclear can be competitive. To do that, we really need to transform how we think, and we're trying to do it here at Oak Ridge. The Secretary mentioned Craig Lamont, and we're working on lightweighting using carbon fiber. Carbon fiber is a technology that will enable a lot of things to happen, but we need to advance it more and more. And we're providing solutions that actually cut the cost by half and increase the production time by 3 times. The panel we assembled this morning has a wide range of expertise and what is needed for the U.S. to continue its manufacturing dominance, and how the DOE and its lab can work with the industry to best accomplish the task. So I'm going to start with Doug Wood. Doug? Okay, raise your hand. Okay. So Doug is the president of the Association for Manufacturing Technology and a lifelong manufacturing professional. Doug's organization has 650 members and provides the manufacturing sector with the latest information on technical development, trade, marketing opportunities, and economies to make sure that they stay competitive in the global economy. Doug also represents industry on manufacturing technologies, matters to the government and trade organizations around the world. Saeed Jahanamer. Saeed is the president of the American Society of Mechanical Engineers. The American Society of Engineers has 110,000 members in 150 countries around the world. Saeed also is the Assistant Director for Federal Partnerships in the Advanced Manufacturing Program Office at the National Institute of Standards and Technology. Saeed has provided guidance on legislative national policy issues related to manufacturing, science and technology, clean energy, and workforce development. Saeed's work in materials and manufacturing science helped guide the development of several key international standards for the industry. Sharon Nolan, Daniel mentioned he visited Eastman Chemical Company, so we're glad to have you here, Sharon. Sharon is the manager of Global Natural Resource Management at Eastman Chemical Company, where she guides the company's worldwide energy program, including a focus on water conservation and reuse and renewable energy. In her career at Eastman, Sharon has held leadership roles in process engineering, plant engineering, corporate quality, information technologies, and utilities division. Sharon is the company's representative to DOE's Better Buildings, Better Plant Challenge program, and under her leadership, Eastman has been recognized by EPA for 8 consecutive years as Energy Star Partner of the Year. Dennis Townsend, at the end. Dennis is the chairman of Townsend Capital, as well as the co-founder of Exalt Energy, which he helped grow into a globally recognized firm in the manufacturing of lithium-ion-based energy storage technologies. Dennis has a wealth of experience that he will share with us related to the battery sector. Dennis's investment have helped fund various opportunities in real estate and more recently in the energy field, including Exalt, as well as a lighting controls company and a domestic oil and natural gas exploration company. Glad to have you all here with us. So I'm going to start with you, Doug, and I'm going to just point some questions to each of the panelists, and then afterwards we'll open the floor for the audience to ask some questions. So Doug, you seem to have a very interesting and relevant position for this session and running the Association for Manufacturing Technologies in the United States. What do you see as the most transformative technologies impacting the manufacturing in the U.S.?
It's interesting. I used to think actually I had the best job in manufacturing up until I heard the secretary talking about how cool it is running the Department of Energy's Oak Ridge Labs. I'm starting to think maybe I got the second best job.
You can join Oak Ridge.
Second best, but I'm a lifelong manufacturer. I grew up in the tool and die industry, and when you look at the things that are going right now in transformative technologies, it's a super cool time to be in manufacturing. And I get a chance to travel the world. I get to see a lot of different things that are going on, study a lot in manufacturing tech space. And the things that really bubble up to the top for me, out of all the whole list of really cool transformative technologies, are really 3, but maybe for a different reason than what people might expect. Certainly what's going on in machine learning, the whole AI space, additive manufacturing, and cognitive automation. And those may seem obvious, but the reason to me that those bubble up to the top is because I see those as really being kind of crossover technologies. They've become, interestingly enough, mainstream across all of the United States. The media picks up on them. You've got schools picking up on them. There's programs on TV about them. When you start to have that kind of interest in those technologies, what happens is you start garnering a lot of attention from investors. And you start to get the kind of public interest, you get the investment interest, and you start getting what you see were huge R&D investments. And those R&D investments in those companies, because now they have the wherewithal, they've got the stock values, they've got the kind of kids coming into those programs, you see an accelerated growth rate of how those technologies are being applied in the manufacturing space. And really right now, it's kind of changing the entire face of manufacturing. You see this whole concept of decentralized manufacturing and a little bit of data centricity happening in the manufacturing space on a regular basis, and the whole concept of microfactories, being able to do mass customization as kind of the norm as to how to go about it. And those technologies are really driving that and creating entirely new business models for manufacturing. And I really think when you look at those 3 and their dynamic impact on the overall industry, they really are the ones that are the game changers.
Thank you, Doug. Saeed, you're the president of the American Society of Mechanical Engineers. So my question to you, what will be the role of the professional societies in technology development, implementation, promoting that, especially in the area of the advanced manufacturing?
Yeah, thank you, Mo. Thank you for asking that question, and I want to thank everyone here for inviting us. And this is really a very exciting conference. Well, as Secretary Perry talked about innovation doesn't occur in vacuum. We learn from each other. We learn from others in the past, and we network, and we talk about what we're doing today and share the information. And then we also archive the information in terms of published papers, right, for the future generation. So the role of technical societies such as ASME is really to provide a networking opportunity for scientists and engineers to get together, discuss the issues, learn from each other, and to develop new ideas and move forward. That's one of the roles. Now, some of the societies, technical societies, also develop standards, such as in ASME. We take what we have learned and develop standards for design, for inspection, for measurement, for public safety. And that is an extremely important aspect. And a third issue that technical societies are known for, and they do very effectively, is partnerships. Through these networking activities, you have people from academia, from national labs, from government, from industry, and also internationally come together and discuss issues.